Hello guys, welcome to Tematan channel. Please, if you are new here, kindly subscribe to this channel and turn on your notification button to get our video whenever we upload new video. I promise you, we'll give you looks of design, and today we'll be looking at Prota structure 2021. Prota structure 2021 is actually, the interface is actually different from previous release of Prota. So if you are using previous release of Prota, I advise that you get 2021 or the latest release, so you will enjoy it better, because there's a lot of improvement in Prota structure, Prota detail, and Prota style. So today we'll be looking at modeling this, designing this shopping plaza, this simple shopping plaza. So this is the ground floor. So we start by creating new project. We'll give it a name. Our new project is shopping. Doesn't allow spacing, of course, you know that. Underscore, then plaza. And I will select the code to use, be it 8110. Then the template. Then OK. That will take us to the interface, the user interface. Okay, here we are. So I will remove this grid, because I for one, I don't like to see this grid. I want my background plain, so I will remove this. Before I remove that, let me quickly bring in the 3D view. This is the plan view, so I'll go to 3D, go to the view, then 3D physical model. I'll click on that. So we have it. So this is the 3D view. So I'll remove the grid and go to display, go to visual interrogation, then go to scene setting, then uncheck the grid. So it has gone. So I'll do same for the plan view, because I don't want to see it. Uncheck the grid. So that's all, has gone. Now we'll start by creating our grids. Start by creating our grid. Okay. The horizontal direction is the number from 1 to 14. The vertical direction we have from A prime to F prime prime. So we model accordingly, right? Here, go to the orthogonal axis generator. Click on that. Any place in the window. Okay, so this is where I click. This is the reference coordinate. Okay, so this is the vertical direction. That direction 1 axis is the vertical direction, then direction 2 axis is the horizontal direction. So we'll modify and put our grid here. So what is it? Let's check it again. We'll start like this. This is A prime, A prime, A prime prime, another that. So going down, right? So since we are starting from the top, going down, so it means our value will be negative. If we are to go up, it will be positive. So we come here and put those values here. So we'll have negative 525. So we separate by comma, then minus 750, comma, minus 3255, comma, minus 1625, minus 3225, comma, minus 1625, comma, minus 3225, comma, then 7 minus 7 minus 750, comma, then minus 525. Okay, so that is for the vertical direction. Then for the horizontal direction, so we impute, since it's not equal, we impute the value. So starting from 1 to 14. So since we are moving to the right, so it's going to be positive. We don't need to impute minus. Okay, if we are going to the left, so that would be minus. So since we are going to the right, so it's positive. So we don't need to put minus. So the first one is 1625, then 3225, 333 meters, like that. So we input those value here. One is we have 1625, comma, 325, 3 225, comma, 3000, comma. I will copy and paste this. This is appearing more than once. I will also 2, 3, like 3 places. Okay. Then 3225, comma. So I have 3 meter into 4 places. I will paste 1, 2, 3, 4. Okay. Then I have 1625, comma, I have 5990, comma. So that is that. So we are done. Then we click OK. Okay, here we do little modification. First of all, extend this grid label. Select this. This is what I want. I want to select this. Right click. Stretch axis. I can stretch this one down. Right. So I will also stretch this, stretch axis. So that is it. So we have from 1 to 13. Okay, let's check if we are okay. Actually ended in 14, right? So we are here, so we include this 750. So what we do, we just right click on this, offset axis, we offset axis, then shift F2, then we put our value 750. Okay, so we have our 14. So that is that. Then let's change this label to suit the architectural provision. If you look at the architectural provision, it's A prime, A, and all of that. So we make changes in that regard. So what we do, we select this. So we make it A prime. We update, that's A prime. We select this, it's A prime prime, A prime prime. We update, okay. We select this, so this is our A now. This is our A, we update. This is our B. E, update. This is our C. C, update. This is our D. Update. E. E, update. Is a F. F, update. Let's see how the F is. F, F prime, F prime prime. Okay. This is our F prime. F, update. Then this is our F prime prime. F prime prime. Updates. So we are done with the green label. Now the next thing we'll do is to do our material setting, do all the various setting, right? So we'll go to setting, thereafter we start our modeling. Okay, in doing that we can go back to building setup. In building setup, we go to material to set our material, right? Column material setting, yes, the concrete grade is 20/25, so cube is 25, that is okay, and all the material here is 25 out 25, so that is okay. Then the steel grade, yeah, you may wish to change this. If you want to change this, you can change this one to 460 if you wish. Okay, but because of the uncertainty on site, sometimes you want to reduce the steel grade, because sometimes the supplier can supply bad steel, and that could be a problem. So because of the uncertainty, so we want to reduce the steel strength to 410. So we'll leave it at 410. Okay, so that is fine. All our steel strength 410. then we'll go to the rebar we want to use for this building. So you as a designer and structural and structural engineer, you know the type of building you are designing, so you know the reinforcement you want to use. So for this building, since it's just a simple one floor shopping plaza, in my column I want T16 maximum till um, 20, right? But here the bar mark is actually donated with Y. So Y and T, they are the same. So T16, Y16, they are the same. So first of all, I will uncheck all this, then select the one that I need. So I need Y16, maximum minimum bar. Okay, this one Y20. So that's okay for me. Right, wall, I don't need to check wall because I don't have wall um, in my design. So I'll go to beam and set my beam. So first of all, uncheck all of them. In my beam as well, I need the Y16, minimum, maximum, Y20. That's okay. That's the bar I need for my beam. Okay, that's then I go to my slab, right? Uncheck all of them. So my slab, I'll need Y10, minimum, maximum, Y12. So that's okay. I'll okay that, right? I don't want to use rib beam, a rib slab, so no need of checking that. Then the links for reinforce for beam and also for column. So I'll uncheck all this and check the one that I need. So I'll need minimum of Y8, Y8, maximum Y10, right, for my links. So that is okay. Let me check this again. If that was okay. That's okay. What is again? Nothing. Foundation, I can just check my foundation. So this is okay. My foundation rebar, do the same thing here. I'll need the Y12 for my foundation. That's okay. Y10, okay. I might as well, let me just choose indicates Y16. So that's okay. Links is the same thing. We selected this before, so that's the same thing. So I'll okay this is okay, right? Then I'll go to my settings center, go to my settings center to see what I can change there. Column and share wall, column design, anything I want to check here? No, nothing here. The parameters, those are okay. The rebars is okay. I like this rebar, these links, so I can check this. Curtailment wall, no, don't need anything there. I don't need to check anything here. Okay, my link spacing, minimal link spacing, I want 50. Maximum link spacing, I want 200. That's what I want, 200. Okay, so I can work in between. So link spacing step 25. Okay, that is okay. I don't so that's okay. Detailing, do I need to check anything here? No, I don't need to check anything. Okay, my lappy length, I can check my lappy length. Lappy length, I will use 15 times diameter of bar. If I'm using 16 diameter of reinforcement, so 50 times the 16, that will give me 800 mm. lapping length. If I'm using 20, 50 times 20, that will give me 1000. So here I will indicate 50, right? Kicker 75, that's okay. I don't want to change any other thing there. Elevation, this one is okay. Schedule, I'll just leave this one the way they are. So let me go to beam. Is there anything I want to check here? No, these ones are okay. This parameter. Um, um, we selected this before, so there's no need. Only thing I would like to check here is the web stick diameter, but we are not going to be using it since we will not have a deep beam. So this web stick diameter is usually when you have 900 depth of a beam and all of that, so you need it to control cracking, right? Okay. Um, this one containment, okay. This one is usually for detailing, so just leave out this one for now. Okay. Cantilever support, so 1.5 or 1.2 times the cantilever length, so that will be the extension of my cantilever reinforcement. 1.5, okay, that's okay for slab. So I would say this is okay, nothing else to change there, right? So I'll create my loading partition, go to wall, right? If you see the default wall here, there is no 225, so I have to create block wall 225 and block wall 150. Though in our design, I don't think we have 150, but I'll come here to create. I'll label this 225 block wall, 225 block wall, right? So I'll create the block wall is 225. So dense block, the unit weight of the block A20. That is too much. In Nigeria, we don't really have that unit weight of block. Our block is not that quality enough. So we can use 15 medium block, right? We can use 18. But let's assume we want to use 18 and 18 is not on the list. You create your own. So what you do, you come to edit material, you come here and you create your own. So delete one there. I can delete one there. Yes. I can create, let's say, let me just say block, right? Then I'll put the unit weight as 18. Then I'll OK it. So here I can come here and select block, right? Then I'll put the thickness of the block, which is 225. So that will give me this. But if you see that this is too much, right? If you study Oyenuga, he recommended, for block 225, lesser load value. So in that regard, I'll come back to this place and use 15. So using 15, we have 3.375 kilonewton per area, right? So not done here. So this is just only the block wall. I will not create the plaster because the plaster is also a load on the wall, right? I'll create plaster. Plaster, I have plaster here 18, so that's okay. My plaster thickness, you can assume 25 per face. So the two face, wall face, back and the front and the back, so that would be 50. But let me assume 30, 30. That might be too much for some people, but let me just take 30. 30 plus 30, that will give me 60. So I'll put 60 here. So this is my value. So that is my wall A load, right, for block 225. So I will say okay to this. Is okay. I've created my wall load. Then the slab load, I'll go and create my slab load. Then I'll come here and create, I'll say I'll just say additional load. Additional load. In my additional load, I'll create what's the additional load? Additional load is screeding on the slab, right? Then ties, MEP, and all of that, right? So I'll first of all create the screed on the slab, right, for ties. So cement, what am I going to use now? My screeding, cement gypsum, cement grout, 25, no. Cement grout with limes, no. Finished concrete 22. Good. So you can create lightweight concrete 14. I can use lightweight concrete for my screed. Though screed is not concrete, it's mortar. So I can create, if what I want is not here, I can come here and create my own. So I can create and say screed. Say screed. What's the unit weight of the screed? I can say 15. Unit weight 15. Then I'll say okay. Then I'll just come here and click on screed, right? The screed thickness, I will put the screed thickness. What thickness am I expecting? Let me say 50, like 2 inches screed. 50. So 0.75 will be my screed weight. But I can as well adjust this one to 75. Okay, but let me just leave it at 50. Leave it at 50. Then I'm not done here. After the screed, we have the ties. Then I will put the ties. What kind of ties do I have? Marble. Polystyrene. What kind of finishes do I want here? Cement. Okay, marble, granite, they're the same. So let me say granite, right? What is the thickness? Let's say 30. 30, but not up to that, no, 20. So we are not done here. We add the MEP load, right, or the ceiling grouting. MEP load, because this one is just a shopping mall, we might not need MEP load, because MEP load, you'll be talking about the HVAC, you talk about the water for sprinkler and all of that. So that is additional load to the slab. So you add MEP load. All right. But we can go with this, or if we want to add more load, we can add ceiling grouting. It's plastering, so let me still use this. Then 1 inch, that's 25. So that would be okay. Additional load, right? At the end of the day, we have this. So we say okay. So the next thing to do now, we start our modeling, right? We start our modeling. So we go to model, we go to column, start with column, right? Our column is 225 by 225, so we input the value 225 by 225. Okay, so where is our column? So I'm going to put my column in grid line A and grid line C, then grid line D and grid line F. The reason is that if I put my column here, this design will not be economical. The distance between here, grid line A, to grid line C is just less than 5 meters. So 450 thick depth beam will be enough. So putting a column here will not be economical for this structure. So I will make that. So use from A to C. That's what we'll be doing. So we have our column here. We have this is A, this is C. We have here A, this is C. Okay. We can put in all this and draw like that, like that, like that. Like this. So this is there. Sorry. I'll have this. Where I don't need column, I can delete. Make column here. Make column here. Make column here. So these are the places I need column. All right, so let's look at the drawing again. So I don't need column in grid line 12D and grid line 12C. Here and here, I don't need column here, I don't need here, I don't need here. So I will delete that. Right. So I'll delete this column, delete this. I will also delete this 3, delete this, delete this, delete this. I don't need that. So these are the ones I need. So what it means is that since I don't need column here, I'll come back to this place. So I will need a column here. Probably need a column here because from here to here, if it's more than 6 meters, I will just need a column here. So I will do the measurement, right click, measure from here. Okay, let me first of all draw the center. From here, I measure from here to here is 3225. So 3225 divided by 2, 3225 divided by 2, that will give me 1612.5. So I'll do offset here, construction offset as it. I'll have 1612.5. So this one, I'll make it a construction grid line, right? I'll double click and off the label, update. So I made it a construction grid line. Okay, so I will now measure from here to here now to see if I can conveniently run a beam. So it's 6.4. Let me not just let me create another column here. So from here, okay, change the same column label, so I can create a column here, create here, create column here, create here, create another one here, and create here. So that is all the column we need, right? So having done that, we connect our column, tie them with beam. So we'll go to beam, right? Our beam 225 by 450 by 450. Okay. I'll connect this to this. Can do it one by one. I can also just go straight. So everything is there. I can run this to this straight. And I can also run it from, oh, sorry. I don't need that. Start all over again. I can run it like this. Run my beam like that. So straight. So you can do that if you can conveniently do it that way. So you can conveniently do this and this. Then this one to this. Then this to this. Right. Then this to this. So I want us to observe something. This is continuous beam. So it's a fixed beam. This one, I can decide to make it a simply supported beam. For me to do that, what I'll do, I'll go to end releases and click on this. Once I click on this, so the end will release. So if I draw any beam in now, so it means this beam I just modeled is simply supported. However, I don't want to use sibling supported because of the cantilever nature of the slab. So I'll leave it at as fixed. Okay, so I'll delete this one. So chain for this. Please, if you are new to this channel, kindly subscribe. So I don't want to put column here. One can go like that. Okay. Um, this is sharp, so that is why we are doing it. I'm doing it like this. I could as well use a wider span of slab. So I don't want to put a beam here. Okay. So this, I can connect this, and connect this. So that is this. Connect this. Connect this. Okay, so for the staircase, we just put the landing beam. The staircase is within 6 to 7, so we put the landing beam. So 6 to 7. So this way we have the staircase. So we put our landing beam here. So a landing beam from here. So that is the, even this we are going to adjust this, but we need to do this using plate definition, right? So before we do that, we have to put our slab. Okay, so we go to slab. Our slab thickness 150 thick, cover 25, that is okay, right? Then the loading, so this is the self weight. So we go to the load we created, additional load. So we click on that, slab additional load. Then the loading, of course, we know the purpose of the building. So it's a shopping in Plaza. So we go to shopping area, click on that. So we put our slab. All right, so that is our slab, but we have cantilever, so we have to model our cantilever. If we are doing that, we can select cantilever. We can select cantilever 6. We can model cantilever one after the other as in like this. Can do this. This is the cantilever limit. Instead of doing one after the other, we can draw the cantilever straight. Okay, so in that case, we can do like this. Select axis, pick axis, then we select axis 13. We select, this is the limit, F prime. We select 14. We select A prime prime, back to 13. So now is a cantilever there, right? So we can also do it this way by selecting, we need to change this. The cantilever will be what now? 6. So we have 8, we have 13, we have A prime. So it's ending here. 7, back to A. So have our cantilever there. Then we'll go like this. 6, we'll go to A prime, right? This one here. A, back to 6. So that's our cantilever here. So we've done that. But there's also another small cantilever at the front here. So we have a small cantilever at the front. So we still need to give that cantilever. For this, you can see, you extend a little. And what is that weight? From here to this 3380. So let me just make it 350. So let's assume 350 cantilever there. So here I'll right click this, offset, shift F2, minus 350. So I've created that. Make it a construction grid, of it update. So I'll create the cantilever there. So it's going to be this 8. So A prime prime, this is the limit, C, then 1, back to A prime prime. So we have our cantilever there. The same thing with this. Select, this, this. So that's our cantilever there. We finish modeling our slab, but we do something here now. We set our slab type automatically. Okay, so we go here, click on select, apply to all story, all slab in the story. So we click OK. Okay, so it has been labeled. So I click OK. Now, before we continue, let's modify our story height before we continue to model the flights. Okay, so we'll come to edit story, we come here. You know, what we got before was 3150 as our story height. So we modify this. Okay, so our foundation is okay. So we okay that. So this has been adjusted. This 800, 850 remain the same. Okay, so there's no problem about that. Now we model these flights. Now we go to we select pick axis. Okay, this is okay, this is okay, is okay, like this, like this. So let's slap it there. Have done that, so we go to plane definition. Go to plane definition. We do the same to define the plane. So we now have plane 2, right? So we look at the points. This is point 1, this is point 2, this is point 3, right? So 0, 0. So point 1 and point 2 will remain as 0, 0 level. That's point 1, point 2 remain at this level. So we'll take this point 3, this point 3 here and here, they are the same. So it will go to minus 850. So we'll come here and input minus 850. Okay, we update. We see this updated, right? So what we do next, right click, move member to plane. We do this. Go to 3D, we check. So this is what we have. Again, this was associated with this, so we move it back. Just the same thing we did earlier. Oh, because of the level it is. So we have this. Remove this, update. So we have it there. So let's do same for this. So we do that. So for this, what we do, we just take it to the level, that 850 level, right? So what we do, instead of using this level 0, 0, we come here and put minus 850. Okay, so put minus 850, then we define the slab. So we define the slab here, this, and this, right? If we go to the 3D, you see the level where it is. So that's the level, right? So we do the plane definition now. Okay, so the plane definition, we go to plane definition. We do same thing, define the plane. This, back to this. That has been assigned, and this is point 1, point 2, point 3. Point 3 will remain the way it is, while point 1 and 2 will go back to the ground level. From 850 to ground level, the height is 2,300. So we put that 2,300 here. So we'll come here and we'll say minus 2,300 minus 2,300. So we update. So they're there. So we right click this, move member to plane. That is okay. And we should have it there. Go to 3D. So we have it. So this is how to model inclined slab. This is how to model staircase slab. Thank you. Please, if you have not subscribed to this channel, kindly subscribe. So we do same for the second side. What will happen? This one, I will just take it to the level. So minus 850 minus 850. Oh, sorry. We go back to that place again and check. So because we did not put negative, so there we go. So from there we can have our slab. Okay, so we draw the landing beam now at this level. So we can check that. So it's at that level. Then the slab. Slab is this, so our slab level will be at minus 850. Okay, so we pick a beam region. So we have that there. We can go to, so there we go.